Welcome back, students. So in this video we will discuss about the working of electric motor. Okay, so you know the working principle of electric motor is when a current carrying conductor is placed in a magnetic field, it will experience a force. So two magnetic field will be there. One is produced by the current carrying conductor and second one is produced by the permanent magnet. So due to the interaction between these two forces, a force will be experienced by the a force will be experienced on the conductor, and the conductor will move either to the left or to the right depending upon the force. Okay. Then the equation to find force is F equal to IBL sin theta. That is, if the angle between the direction of current and the direction of magnetic field is 90 degree, then it will experience a force. If no force will be acting on current carrying conductor, if the angle between the current carrying conductor and the direction of magnetic field is 0, no force will be acting on that current carrying conductor. Okay. Now we can increase the strength of the force by increasing the current, magnitude of electric current, by increasing the magnitude of magnetic field. Means if you replace a stronger magnetic field, then if you increase the length of the conductor. Okay. So that's electric motor. So an electric motor converts electrical energy to mechanical energy, and we are using electric motor in many electrical devices. If any device is having a rotating part, then it's having an electric motor. In your electric fan, in your washing machine, in your CD player, in your tape recorder, in all these things, a rotating part is there. That means it's having an electric motor inside it. The capacity of that motor will be different. For a small toy car, if it is controlled with the help of a remote, then it's having an electric motor. That motor and the motor used in our grinder or electric mixer is not of the same type, but the working principle is the same thing. Okay, the working principle is the same thing, but the capacity of that motor used in different appliances will be different. So the working principle of electric motor is a force will be experienced on a conductor when a current carrying conductor is placed in a magnetic field. Electric motor converts electrical energy to mechanical energy. Okay. So now we will discuss what are the main parts of an electric motor. The main parts of an electric motor is an armature. Armature means it's a rectangular armature. This one is the armature. This rectangular coil, that is known as the armature. Then electromagnet. Instead of electromagnet, here two permanent magnets, the two poles of permanent magnet is shown. Normal case we will use electromagnets. Then commutator or split rings. Here you can see P and Q, that represents a split ring. Okay, it's not complete ring, it's a split ring. Then brushes, X and Y brushes. It's of graphite brushes, then battery, then battery. So, these are the main parts of an electric motor: armature, electromagnet, commutator or split ring, brushes, then battery. So, when you connect it to a battery, when the key is in the on state, then current will flow through this way. The current will flow through from the positive terminal of the battery to the brush X, then to the split ring P, then A, B, C, D, then to the split ring Q, then to the brush Y, then to the negative terminal of the battery. That is the direction of current flow. So, when you switch on the circuit, the current will flow from the positive terminal of the battery to the brush X, to the split ring P, then to the A, B, C, D, then to the split ring Q, then to the brush Y, then complete the circuit to the negative terminal of the battery. Okay. So, this external circuit, that is a function of this brush. The brush will connect the internal circuit to the external circuit. The brush will connect the internal circuit to the external circuit. So, this one is the external circuit, this portion is the external circuit, this portion is the external circuit, and the other portion is the internal circuit. So, the brush will connect the external circuit to the internal circuit. Okay. Now, we will discuss the working of electric motor. We will discuss the working of this electric motor. So, in the previous diagram, the split rings are represented as P and Q. The brushes are represented as X and Y. Here it is represented as split rings as C1 and C2, brushes as B1 and B2. Okay. So, when you switch on this current, this is the direction of current from the positive terminal C1, then it passes, from the positive terminal it will flow through B1, then to C1, then A, B, C, D, then to C2, then to B2, then to the negative terminal of the battery. That is the direction of the current flow. So, we can write the direction of current flow here from the positive terminal of the battery to B1 to C1, then to A, B, C, D, C, D, then to C2, then to C2, then to B2, and then to the negative terminal of the battery. Okay. So, that is the direction of the current flow. From the positive terminal of the battery, the current will flow through B1, C1, A, B, C, D, then to C2, B2, then to the negative terminal of the battery. Okay. Now, using Fleming's left hand rule, we will find the direction of force, in which direction the force will be acting. We know it is a rectangular conductor. So, only in this portion AB force will be acting, AB and CD. On the space AB and CD force will be acting, no forces will be acting at this portion BC and AD, this portion no force will be acting, because they are parallel to the direction. The current direction of current is parallel to the direction of magnetic field. The direction of current is parallel to the direction of magnetic field. So, no force will be acting on BC and AD. Okay. Then, this portion AB and CD, because the direction of current and the direction of magnetic field are right angles to each other. So, they will experience a force. They will experience a force. So, we need to find the direction of force. In which way? That conductor, that AB, in which direction force will be experienced by the conductor AB. So, magnetic field direction is given by, this is the direction of magnetic field. Magnetic field direction. This is the direction of magnetic field. This is the direction of current. In AB, this is the direction of current in CD. Okay. Now, so stretch the three fingers of your left hand in such a way that the magnetic field is points in the north-south direction. The magnetic field is points in the north-south direction. The current is in the upward direction. The current is in the upward direction. Okay. Normally, we will keep the motor in a horizontal way like this. Horizontal way like this. We will keep the motor like this. Okay. So, the magnetic field is in the north-south direction. The current is into this direction. The current is in this direction. Okay. Into the board. Okay. The current is flowing into the board, that is represented by in the upward direction. Okay. The current is flowing into the board. So, in which direction the thumb points? The thumb points in the downward direction. Thumb points in the downward direction. So, this AB, this side AB will experience a force in the downward direction. That side AB will experience a force in the downward direction. Now, what about the CD portion? Now, magnetic field is in the same direction. Now, in which direction the current? The current is moving towards you. Okay, the current is moving towards you. Okay, so in this direction. So, in which direction the thumb denotes? The thumb denotes in the upward direction. So, that CD portion will move upward. CD portion will move upward. AB portion will move in the downward direction. So, if you consider a paper like this, and if I wrote it A, B, C, D like this, if I wrote it like this, A, B, C, D, this AB side will move downward and CD portion will move upward. Normally, a motor is placed like this. Okay. So, AB portion will move downward and CD portion will move upward. So, it will rotate in this way. AB portion, this one is AB portion, it will move downward. So, CD portion will move upward. So, this object will move in this direction. In this direction. In which direction it is moving? It is moving in the anti-clockwise direction. That object will be moving in the anti-clockwise direction. Okay. The coil will rotate anti-clockwise direction. So, the amount of force acting on this side AB and this side CD will be same. The magnitude of force will be same, but the direction of force will be different. The direction of force will be different, and due to that this coil will rotate, and due to that this coil will rotate. Okay. So, on this side AB and on the side CD, they will experience the same amount of force, but in opposite direction. And due to that, this coil will rotate in the anti-clockwise direction like this. Okay. Now, whether our fan will rotate, one side it will rotate like this, the next moment whether it will rotate like this, it will continuously rotating in the same direction. So, in the next half cycle, that is after 180 degree rotation, now you can see after 180 degree means after half rotation, that is after 180 degree, here you can see now CD is at this position. Already AB was there. After 180 degree rotation or after half rotation, now CD is there in place of AB. CD is there in place of AB and AB is there in place of CD. AB is there in place of CD. Okay. From this diagram you can see, after half rotation, means after 180 degree rotation, now CD is there in place of AB and AB is there in place of CD. Now, what is the direction of current flow here? Now, the current will flow from the positive terminal of the battery, to B1, then to C2, then it flows from D, C, B, A, then it flows through C1, then it flows through B2, then to the negative terminal of the battery. Now, the direction of current flow is from the positive terminal of the battery to B1, then C2, then D, C, B, A, then to C1, then to B2 and then to the negative terminal of the battery. Okay. So, now what will happen is that CD will move in the downward direction, because the force experienced is in the downward direction. Okay, because the force is experienced in the downward direction. So, CD will move in the downward direction, AB will move in the upward direction. So, CD will move in the, now this portion is CD. Okay, CD will move in the downward direction and AB will move in the upward direction. Okay, now you can see this way. So, A, B, C, D. AB is this portion. Okay, this folded portion is AB and this folded portion is CD. So, during the first half rotation, I will keep it like this. When it rotates first half in the anti-clockwise direction, this AB will move in the downward direction like this. Okay. Now, CD is in this side. CD is here. Okay. Now, CD will move downwards and AB will move upwards to a continuous rotation. To complete a continuous rotation, CD will move downward and AB will move upward. So, this portion is CD. CD will move downward, AB will move upward and will reach the same way. Okay. So, that is the working of an electric motor. Okay. Now, this two split rings are there. That split ring will reverses the direction of current. That split ring reverses the direction of current. Okay. That way it is known as a split ring commutator. A split ring commutator is there. The function of this commutator is to reverse the direction of the current. That you can see. In AB, in first half rotation, the current is flowing from A to B. During the next half rotation, the current is flowing from B to A. Reverses the direction of current. Here also you can see. During the first half rotation, the current is flowing from C to D. During the second half rotation, the current is flowing from D to C. So, a commutator is there. The commutator reverses the direction of electric current. Here, the split ring will act as a commutator and it changes the direction of the electric current. Split ring act as a commutator and it will changes the direction of electric current. Okay. This carbon brushes are not moving one, they will not rotate, they are stationary ones. Okay. This carbon normally it is not made up of carbon, it is an allotropy of carbon, that is graphite. Okay. That is graphite brush. Graphite is an allotropy of carbon. Okay. So, that brushes are not rotating one, that is a stationary one. We know carbon is an insulator, but graphite is a conductor of electric current. Graphite conducts electricity. Graphite means your pencil lead, that is graphite. It will conduct electricity, that is an allotropy of carbon. Okay. Then, why we are using this graphite instead of any other material? Why we are using this graphite? The reason is that it is having high melting point. It is having high melting point. Since this split ring touches this brush, the split ring will be in contact with this brush. So, the split ring will touch the brushes and friction will be there in between the split ring and the brushes. Friction will be there in between the split ring and the brushes. So, due to friction, heat will be generated. Due to friction, heat will be generated. So, graphite is having high melting point. Okay. We can't use any other material, copper, all those things will melt away due to the heat produced by the friction between this split rings and this brushes. Okay. So, that is about electric motor. Then commercial electric motors uses electromagnet in place of permanent magnet. Commercial electric motors uses electromagnet in place of permanent magnet, so that we can increase the magnetic field, magnitude of the magnetic field. In that way we can increase the efficiency of the motor. Large number of turns of conducting wires in the current carrying coil. Here only one turn is there. Only one rectangular wire I consider. So, if you use a n number of turns, means the length of that coil, length of that conductor increases. So, it will experience more force. And a soft iron core on which the coil is bound. The soft iron core on which the coil is bound plus the coils is known as the armature. It enhances the power of the electric motor. Okay, we can increase the power of the electric motor by these three methods. Okay. Then blue question, state Fleming's left hand rule that we already discussed. You just mark the answer in page number 231. Then the working principle of electric motor, that also is there in page number 230. Then what is the role of split ring in an electric motor? That split ring reverses the direction of current. Okay, the split ring reverses the direction of electric current. That is the main use of this split ring. Split ring in an electric motor reverses the direction of current in the armature coil of the motor. So, the direction of force acting on the two arms of the coil also reversed. As a result, the coil of this motor rotate continuously in the same direction. So, split ring changes the direction of the current. So, if the direction of current is changed, means the direction of force acting on the two arms of that rectangular coil also changes. So, the coil will rotate continuously in the same direction. The coil will rotate continuously in the same direction. Here the coil is rotating in the anti-clockwise direction. Okay. So, after half rotation, again the coil will rotate in the anti-clockwise direction itself. That is done with the help of the split ring commutator. So, split ring commutator reverses the direction of current through this coil. So, the current direction changes is reversed, means the direction of force also reversed. So, the conductor will rotate in the same direction in a continuous way. So, that is a function of that split ring commutator. Now, the main two organs in our human body where the magnetic field produced is significant, that is the heart and the brain. The magnetic field inside the body forms the basis of obtaining images of different body parts. This is done using a technique called MRI scanning, magnetic resonance imaging, MRI. Analysis of these images helps in medical diagnosis. This magnetism got important use in medicines. Okay. Okay, thank you.